So this is x minus 2, x plus 1. And so we get x square minus x minus 2. It is 2 raised to 2. So we get x square minus x minus 6 is 0. Again, the product is negative 6 and the sum is minus 1. So that is negative 3 and 2. So here if I take x out, so you get x minus 3 and you get x minus 3. So x plus 2. So x minus 3 is 0, x is equal to 3, or you have x plus 2 is 0, so x is negative 2. Now, again, so log of x to the base a, x needs to be positive, so therefore we reject it. Our answer is x is equal to 3. Okay, move to the next question. Okay, now in this question, we have to prove it. So prove that this is same as this. Okay, so let us say that the left-hand side, so log base 1 by root b, and this is root of x. So I'm calling it equal to y. Okay, so if I convert the logarithmic form to the exponential form, what do I get? I get root of x is equal to 1 upon root of b raised to y. So this can be written as b raised to minus half raised to y, and I'll get b raised to negative y upon 2 as root of x. Or I'll get x as b raised to negative y upon 2 squared. What does that give me? That gives me x is b raised to minus y. Okay, that gives me b raised to minus y because that will get multiplied. Now let us say, can we prove that equal? So this is the right hand side. We have negative. Okay, so let's that equal to some z. So first of all, this negative sign needs to go. So x raised to minus 1. So this is x raised to minus 1 is b raised to z. Okay, so this is 1 upon x is b raised to z. So x is b raised to minus z. So here you can see that this is 1, this is 2. So what can we say? From 1 and 2, the base b is equal. And on the left hand side, it is equal to x. So the power needs to be same. So that is y is equal to z. So I've considered the left hand side as y and the right hand side as z. And therefore, the left hand side is equal to the right hand side. That's proved. Okay, you can play it again, hear it again, pause the video wherever you want to understand the step again. The left hand side, log to the base 1 by root of b, root of x, can be written as log okay. So this is log x raised to half. This is b raised to negative half. So that will be half log x and negative half log b. So this will be negative of log x and log b. Okay, now let's try for this one. So the right hand side is negative of log x to the base b, and change of base is log x log b. So that's proved. So the left hand side is equal to the right hand side. So this is another way, a logical way, looking at the formula. Log a to the base b is log a to the base c upon log b to the base c. It's change of base. I change the base to 10. Now let's go to the next question. Okay, this is another proving question. Give it a try. So left hand side is log of x squared and b to the power 4. So this is log x squared, log b to the power 4. So this is 2 times log x. This is 4 times log b. This is half times log x log b. So the right hand side is root of log x b, that is root of log x, this is log b. So this is x raised to half times log x log b. Left hand side is equal to the right hand side. Proved again. Moving ahead to the next question. So log 2 is given as x, log 3 is given as y. You have to find log 12. So that means you have to write log 12 as log 2 and log 3. So we factorize this, or prime factors. So this is 6, this is 3, this is 1. So basically 12 is 2 into 2 into 3, that is 2 squared into 3. So when I say log 12, I can call it as log of 2 squared into 3. So this is log 2 squared plus log 3. This is 2 times log 2 and log 3. So this is x and this is y. So that is 2x plus y. So we have to write log 12 in terms of x and y. Okay, so if we go to the next question. Right, so log 2 is x, log 5 is y, and this is log of 200. Okay, pause the video, give it a try. So log 200 is 2 into 100. So log 2 plus log 100. Log 2 is x, log of 100 is 2. So we get the answer as x plus 2. Over here, we did not require to use log of 5. Okay, next question. Okay, log 2 is x, log 3 is y, log 7 is z. This is given to us. So the first step is log 14 minus log 3. Log 14 is 2 into 7. So log 2, log 7, log 3. Log 2 is x, log 7 is z, and log 3 is 1. So this is what we got. Okay, this is the next question. Pause the video and give it a try. This is log 0.4 to be written in terms of x and y. So this is log 0.4 is log 4 by 10 is log 4 minus log 10. Log 4 is 2 squared and log 10 is 1. And this can also be written as log 2 into 5. So that is 2 times log 2 minus log 2 minus log 5. That is log 2 minus log 5. And log of 2 is x. So x minus y will be the answer. Let's go to the next question. So over here we have 6 into 1000 and 6 into 1000 upon 7. So this will be log 6 plus log 1000 minus log 7. And 6 is 3 into 2. This is 3 minus log 7. Log 3, log 2, log 7, log of 3 is y, log of 2 is x, and here you have z. So x plus y plus z minus z and plus 3 will be the answer. Right, we'll go to the next one now. Okay, so log of 0.04. So this will be 4 upon 100. So this is log 4 minus log 100. So this is 2 log 2. This is minus 2. 0.3010 0206. So this will be negative 1. This will be negative 1.398. That's the answer. Let's go to the next question. We have to find x. Okay, so here the first property, remember these powers need to go up. So let's do that first. So here you have 16 by 15 raised to 7. 25 upon 24 raised to 5. 81 upon 80 raised to 3. Okay, then we have to write it like a single log. So there is a plus. So this will be 16 upon 15 raised to 7 times 25 into 24 raised to 5, and you have 81 upon 80 raised to 3. This is log of x. So taking anti-log, we will get 16 upon 15 raised to 7, 25 upon 24 raised to 5, and 81 upon 80 raised to 3 as x. So then, of course, when you simplify this to an extent to get the value of x, you will get the answer. So how to solve this further? If you see, all these numbers can be broken down as powers of 2, 3, and 5. Like 16 is 2 to the power 4, and this is 3 into 5. This is raised to 7. 25 is 5 squared, and 24 is 8 threes are, so that is 2 cube into 3 raised to 5. Then 81 is 3 raised to 4, and 80 is 5 sixteens are, that is 2 raised to 4 raised to 3. So we have 2 to the power 4 raised to 7, 5 to the power 2 raised to 5, 3 to the power 4 raised to 3. This becomes my numerator. 3 to the power 7, 5 to the power 7, 2 to the power 3 raised to 5, 3 raised to 5, 5 to the power 3, and 2 to the power 4 raised to 3. Okay, so one more step and things will be very clear. This is 28, this is 10, this is 12. This is like here you have 3 to the power 7 and 3 to the power 5, that is 3 to the power 12. 5 to the power 7 and 5 to the power 3, so 5 to the power 10. This is 2 to the power 15 and 2 to the power 12. 2 to the power 15 and 12, that is 27. So here we are left with just 1 2 on top, so x is equal to 2. So remember, this is reducing it to the powers of prime numbers and solving this. Okay, so these were some of the questions in which we have applied the rules of logarithm. I hope you have followed what we have done. Do practice more questions.